Welcome to lesson 3.8 on regular tessellations. Our objective with this lesson is to explore side and angle relationships in regular tessellations. This is one of my favorite lessons. I really enjoy talking and teaching about tessellations. I think they're really interesting and really cool to look at. And you can see them in several places, and probably you don't even realize or didn't realize that was a tessellation. The one thing to remember with tessellations is that in order for it to tessellate, it cannot have any overlaps or gaps. So be careful when we talk about gaps and overlaps, because then that shape does not tessellate if that is the case. Okay, you will need your journal for this, and I did say that in class, so hopefully you have your journal. You're going to go to page 89 in your journal, and what I want you to do is I want you to cut out the shapes. But before you cut them out, you're going to need to be doing some folding before you cut. And the reason you're folding, and I will talk about this in class on Friday, even before you leave for the weekend, is because you're going to have several then after you folded it and you cut them, you'll have several. So that's the point of it, so you can see what shapes actually do tessellate and which shapes do not tessellate. So there are 5 there, and once you fold the paper and then you cut it, it will end up with several, and then that will give you an example of what shapes are going to tessellate. So a tessellation is an arrangement of repeated closed shapes that cover a surface so that no gaps exist, and that's really the key. And a tessellation with shapes that are congruent, regular polygons, is called a regular tessellation. And in yesterday's lesson, it talked about what is a regular polygon and what polygons are. So hopefully you do know what polygons are, and the regular polygons are called a regular tessellation, which I hope makes sense. All right, let's move on. So regular tessellations. A regular polygon is a polygon in which all sides are the same length and all angles have the same measure. Circle the regular polygons below. So we are going to do a lot of this in class, but I do want you to be thinking about which of these are regular polygons. Now, if you want to draw them and or just write the names of them, that's fine too, but please write that on a piece of paper, which ones you think are regular polygons. Now it says in the table below, write the name of each regular polygon under its picture. Then, using the polygons that you cut out from activity sheet 3, decide whether each polygon can be used to create a regular tessellation. Record your answers in the middle column, like yes or no, and in the last column, you're going to use your geometry template to actually draw that. So the part that you're going to do at home is labeling the polygon and writing yes or no. Yes, it can tessellate, or no, it cannot tessellate. We're going to work in class on drawing some examples of the tessellations, and if it does tessellate, using our geometry templates. So you don't have to worry about that last one. It says use your activity sheet polygons to determine whether each shape can create a tessellation without any gaps. Now remember, the key to a tessellation is no gaps, no overlaps. So you're going to answer the question here and what type of polygon it is, and a yes or no right here is if you think it does or does not tessellate, okay? And then we'll actually work on that in class, okay? And there's 2 pages of this. So basically what I want you to do is make sure you have your journal, because this will come in really handy. And then it says which of the polygons can be used to create a regular one, and explain how you know that they are the only ones. And again, what's the difference between a regular polygon and a polygon that is not irregular, or not a regular polygon? And that'll help you with those questions, okay? So hopefully that again makes sense to you. Now remember, you're just answering the first 2 columns as to what you need to do. So you don't have to answer anything besides the name of the polygon and if you think it tessellates or not. So if I were going to do the first one here, I would write equilateral triangle on it. So I would make sure that I have that. And you can even write EQ if you want. then I'll know that's an equilateral triangle. And then you can write yes or no. And an equilateral triangle does tessellate. And hopefully you know that. Okay, we're going to move on, and I'm going to let you finish the rest of them. Okay, so hopefully you did know that one. And moving on, and if you have your shapes, it's going to be nice because you're going to be able to actually see them and put them together to see if they do tessellate. So on to our last, and this is the one thing I do want you to look for at home or in a magazine. It says a tessellation is an arrangement of repeated closed shapes that completely covers the surface without overlaps or gaps. Sometimes only one shape is used in a tessellation. Sometimes two or more shapes are used. So in this shape right here, or in this tessellation, one shape is used. But if you look over here, we have two different shapes being used. So, and that can happen. So now it says collect tessellations. So look in a newspaper or newspapers and magazines, ask people at home to help you find examples. And you can cut them out and bring them in. If you want to tape them on a piece of paper, that's fine too. But just see if you can find a couple. If you can't find tessellations in newspapers or magazines, look around your house at furniture, wallpaper, tablecloths, clothing, and then just sketch one on a piece of paper if you're not able to find one. So just remember, and I want to show you this here. Sorry. Dang it. Okay. So I wanted to show you. Okay, here we go. So a regular tessellations are named by giving the number of sides in each polygon around a vertex point. A vertex point of a tessellation is a point where vertices of the shape meet. So right here in the center is what they're talking about, and that's where the vertice, and we talked about that because we kind of I showed you when I divided up that circle that we could make the 4 right angles. So there's your vertex, in the center there. For example, the name of the rectangular tessellation above is 4 by 4 by 4 by 4. There are 4 numbers in the name, so there are 4 polygons around each vertex. So each of those numbers tells the number of sides in each of the polygons around a vertex point. The numbers are separated by periods. There are 4 4-sided polygons around each vertex point. Look at the tessellation below. So now we have a different tessellation below. Okay. How many shapes meet at the vertex? So if I look at my vertex now, and I go in here and I circle my vertex, how many shapes are around that vertex? How many sides does each of the polygons have? And hopefully you know that. So what would be the name of this tessellation? So I want you to think about that, okay, and write down what you think it would be. So if a square is a 4 by 4 by 4 by 4, what is this? What would these triangles be? So think about that. So anyways, your assignment then as to what do I need to do so Mrs. Heath can clarify for you. Make sure you brought your journal home and you cut out these shapes because it will help you with your tessellations or deciding if it tessellates or not. So you will write yes or no on each of these and what shape it is. You're not going to draw the examples. You're just going to write yes or no. So you definitely are going to need your journal, okay? And so you're just writing the name of it, the name of the polygon, and if it tessellates or does not tessellate. So that's that. And then on the last page, all I want you to do is write down whether or not, or how many shapes are around the vertex, how many sides it has, okay, and what is the name of the regular tessellation. So up here, they said it's a rectangular tessellation. So what kind of tessellation would this be? Okay, and you don't need to do number 4 at all, so don't worry about number 4. And then if you can find an example to bring in, that would be great. Find something you can cut out, something you drew if you don't have any magazines or newspapers at home. That would be fine too. Okay, so let's go back and see that we did complete our objective, and it's to explore side and angle relationships in regular tessellations. And I think we did that. And again, tessellations can be a lot of fun. So take your time with this and enjoy working with tessellations. And we'll work some more in class on this on Monday. Have a great weekend.